All right, good morning. So today we're going to be looking at atomic structure. We're going to look at beryllium this morning. And we're going to look at the tiles. So this would be the same tile that you would see on the periodic table. This tile is going to have the symbol, the atomic mass, and also the atomic number. So we have a tile here. The element that we'll be working with is beryllium. Beryllium's atomic number is here. And my atomic number is going to tell me the number of protons. It also tells me the number of electrons. So atomic number, that's going to equal my number of protons. It also equals number of electrons. So it equals both of those. And for the atom's identity, we always look at the number of protons. So this is the atom's identity. It's kind of like its social security number. So anytime we say atomic number 4, that's only going to be dealing with beryllium. If we were dealing with hydrogen, that's atomic number 1, so forth and so on. So we always look at this top number. This is his identity. It equals the number of protons. It also equals the number of electrons for an element in their elemental state. All right, so we have some other information here. We have this number at the bottom. The number at the bottom is going to represent our mass number. Or this is the average atomic mass. So if we were to go in nature, we would see beryllium that has 4 protons, 5 neutrons, and then we would see other isotopes. So sometimes it can lose or gain neutrons, and we'll see those other isotopes. This is the average of all the isotopes that exist in nature. So this is the average atomic mass. This is its mass number. The mass number equals the number of protons plus the number of neutrons. All right, so mass number equals number of protons plus the number of neutrons. Atomic number equals number of protons. It also equals number of electrons. So that's a difference that I definitely want to make sure that I'm thinking about. Atomic number is the number of protons. It also equals the number of electrons. Mass number equals number of protons plus the number of neutrons. So from here, this is just mathematics. So I use this top number to find the electrons, the protons, and then now I can use this to find the number of neutrons. So if we did a little bit of math, let's subtract both sides by number of protons. Also subtract number of protons over here. So now we have, if I want to know the number of neutrons, that's just going to be equal to my mass number minus my number of protons. The number of protons. All right, so number of neutrons. The easy way for me to think about that is bottom number minus top number. And that's only for element tile. But it'll always be big number minus small number. So if I want to know the number of neutrons, I'm always going to do the bottom number minus the top. Well, the biggest number minus the smallest number. All right, so now as we build our atom, what we're going to do is we're going to take this information. So I know that this one has 4 protons. It also has 4 electrons. And then if I wanted to find the number of neutrons, bottom number minus the top number, that would be 5 neutrons. So here, our number of protons equal 4. Number of electrons are also equal to 4. And then number of neutrons 9 minus 4, that's going to be 5. So I'll use number of protons, number of electrons, bottom minus top, that's going to give me number of neutrons. And then from here, now we can draw it out. So we'll have 1, 2, 3, 4, 5. So I have 5 neutrons. We also need 4 protons. 1, 2, 3, 4. 4 protons, and then this is going to represent my nucleus. So I'm going to kind of put that as a shell to represent. All right, so this will represent my nucleus. And so we can see that most of the mass is going to come from my nucleus. So protons and neutrons equal the mass. The electron is more like a hair. I used to have hair on my head, but not as much anymore. So if I were to, I'm 165 pounds. If I pluck a hair, I'm still 165 pounds. This atom is, average atomic mass is 9. If we pluck one of those electrons, it's still 9. So it's really, really, really light. So after that, we have orbitals. So they're not going to actually be on this line, but the line represents a high probability of finding an electron in that space. So although you wouldn't see it online, it's going to be moving constantly everywhere. This line represents, okay, you're pretty likely to find 2 electrons here. Out here, you're going to find 8 electrons in a different energy shell. So the first one, he holds 2. So I'm going to put 2 electrons in that first one. So we have 2 electrons, and then this one can hold 8. We don't have enough to fill it up. We only have 2 left, so I have 1, 2, 3, 4. And so I'm only going to put 2 in the second shell. Although he can hold 8, he's not going to be full. So we have our masses here in the nucleus. The protons and the neutrons. I know my mass number is protons and neutrons. So the majority of my mass comes from my nucleus. And then outside that, we have the orbitals. This is a region in space where you're likely to find electrons. And so we have 5 neutrons, 4 protons in the nucleus, and then 4 electrons on the outside. Let's see.